Hello everyone, welcome back to my YouTube channel. So this video is going to be the step 3, or you can simply say in the whole credit scorecard models, which I am telling you the whole methodology. Today is going to be the session number 3, or you can say part number 3, where we are going to discuss about step number 5 and step number 6 when you are building an application or a behavior model. Okay, so now without wasting your time, let me take you forward. Okay, and if you're coming to my channel for the very first time, I would request you to scroll through the previous video so that you can get the full context of this particular video. Okay, so the topic for today is going to be obviously discussion about step 5 and step 6 for building a credit scorecard model. And simply the step 5 is, so let's talk one by one, okay, rather than going in a hurry. So I will first talk about step 5. So step 5 is called variable reduction. Variable reduction. So obviously, as the name also says, what is the meaning of variable reduction? When you are trying to reduce the variable before building your model, obviously, because when you are creating a model, so you always try to avoid the unnecessary noise. And what is the meaning of unnecessary noise? Unnecessary columns. So simply you try to remove the unnecessary columns which are there in your data. Now to remove the variable, okay, or basically to perform this particular step, which is variable reduction, there are sub process, like 4 sub steps which you need to follow. So what are those? Number 1 is regulatory reduction, regulatory, or we can say exclusion. So all those exclusions which are suggested by the regulatory body of that particular country, let's say for example in India, Reserve Bank of India is regulator. I'll give you more example. Now step 2 here is calculating the IV. IV stands for information value. This is sub step number 2. Then sub step number 3, that is weight of evidence trend check. This is your third sub step. Then fourth sub step here is variable clustering. Variable clustering, or we also call it multi-collinearity. Sorry about my bad handwriting, guys. So these are the 4 steps which we are going to talk in this step number 5. Let's talk one by one now. Let me take a good color pen here. Let me make it maybe dark. Okay, now. So first step is always regulatory exclusion. So as per the regulatory, what is regulatory? Regulatory is the regulatory body of that particular country. Let's say in Canada it's different, in India it's different, everywhere it will be different. Now as per them, if you say the exclusion, so they have said that we never need to take a call when we are giving a loan on the basis of the color of the skin of the customer, whether the customer is brown, white or black, whatever it is, it should not affect. Then race. We should not do any discrimination on the basis of the race of the people, on the basis of religion. We should never be biased on the basis of the religion. We should never be biased on the basis of gender or age. So these are some of the exclusions which are driven by regulatory body of the country. For example, in India, I just said Reserve Bank of India is a regulatory body. Okay, this is pretty much clear. Now in US there is a Fed government which act as a regulatory body. So you need to make sure that you are following all those exclusions from your data. Now let's talk about the second point. This is an important one. Second is about IV value, which I mentioned here. Now information value is what? Information value is a measure of prediction power. Okay, it's a measure of predictive power. What is predictive power? Like how good a variable is, okay? Predictive power of a variable to separate event from non-event, okay? Measure of predictive power to separate event. What is event? Event is default. Measure of predictive power to separate event and non-event. This is pretty much clear, okay? Higher the value of information value is higher the separation power, okay? So higher IV value is a good value. Higher IV is good. That is one thing you should always remember, okay? So the variable with the high information value has a higher predictive power. The more IV number is there, the more powerful variable is that, okay? Now IV value cutoff is used to reduce the variable, okay? It's an important point. IV cutoff used to remove variables. Always make note of this. Let's go a bit down. So I think IV value is fully clear to all of you, information value concept, okay? Now let's talk about the mathematical part of that. What is the calculation of IV value? IV is equal to summation of, okay, distribution of good minus distribution of bad. This was a summation of distribution of good minus distribution of bad multiplied by weight of evidence, okay? Then you have a formula of weight of evidence. Obviously this is your equation number 1. So now obviously you can think what is the formula of weight of evidence. I told in the previous video also, but let me repeat it. So it's the log value of distribution of good divided by distribution of bad. This is pretty much clear. Equation number 2. Okay, I think it should be clear. Distribution of good matlab good customers. That means the people who are good in your database, and bad is the people who are bad in your database. So as simple as that. Now let me make a table of information value that so that you know in real world how it actually looks like. So I'll keep IV at a place and then we'll have the predictive power. So let's say IV is less than 0.02. So this is one grade, and if it's between 0.02 to 0.01, this is one, not 0.01, it's 0.1. Okay, let me correct this one. Yeah, now it will be 0.02 to 0.1. Then from 0.1 to 0.3, 0.3 to 0.5, and if it's greater than 0.5. So these are the values of the information value. That's how usually this looks like in real world. Now predictive power, if it's less than 0.2, this no predictive power. So we call it no PP. If it's between this particular grid, then it's a weak predictive power. If it's between 0.1 to 0.3, this is a medium predictive power. If it's 0.3 to 0.5, then it's a strong predictive power. Then if it's in case the value of information is greater than 0.5, that is a very vague case. So we call it too good to be true. Too good to be true. So in such case, you need to measure again and again whether your predictive power is so strong, because that is really a strong predictive power. That means without that variable, you cannot make your model. That is very rare. Okay. So this is how the whole concept of IV value works, guys. Okay. I hope the IV concept is fully clear to all of you. Okay. Now I'm moving forward and I'll talk about the further step, which is WOE trend, which you can see here. Okay. WOE trend. So let's talk about weight of evidence. So weight of evidence. Okay. So weight of evidence trend. This is topic next. Trend. Before I start this, okay, so the developer who is developing the model, developer need to check the trend of the weight of evidence. So the first point here will be the model developer will check trend of variable that which need to be selected. That is one. On the basis of weight of evidence, the developer will check the trend. Select the variable that have monotonic weight of evidence. Variable with monotonic weight of evidence should be selected. Okay. Then third point is try to merge the beans to make the weight of evidence as monotonic. Okay. Which I said in the previous video also. This is point 1, then point 2, point 3. Try to merge bins. What are bins? I already explained it. Okay, so I think you should be all knowing that. If you don't know that, I would really request you to saw the previous video. I'll just give a brief here. Bin is a collection of similar type of values in a variable. Okay, now try to merge the bin to make the weight of evidence. Okay, to make the weight of evidence as monotonic. Try to merge bins to make it monotonic, like similar type of. Okay, then the next point here is going to be, the fourth point will be drop variable with no trend. Always try to drop the variable which are not showing any trend. Drop variables with no trend. So there can be several variables, guys. Okay, there can be any variable. Let's say I'll talk about one example of this point number 4. Let's say in data. So you have a kind of a residential column. You have a residential column which talks about whether the person was there on rented house or he owns a house. Okay. And then let's say one parental house. So these are some of the situation. If you see, this variable is having so many values, okay, and you are not able to draw a pattern here. So some of the cases can be that a person got demised, right? The person is no more. So that is an exclusion. But if a person is keep on changing the rented apartment, right, that is going to be a kind of a strange trend. If you see a customer, let's say name Mike. Mike is changing his house every 6 months. So that is a strange thing. You should always make sure that you are noticing such type of things in your data. So that is the overall meaning of the weight of evidence trend, that in this particular variable you need to check the weight of evidence for this particular variable, and if it looks any suspicious without any trend, then you need to drop that particular variable. I hope this is clear to all of you at the moment. Let's move forward now. Okay, how the weight of evidence overall graph looks like. Let me make that graph clear to you, so that you have a visual knowledge also. It's very important. Okay, so on the one side in US we have FICO score, just like in India we have CIBIL score. So all the Indian will relate with this. Let me make a graph here. So now here I'm talking about, let's say, percentages. What are these percentages will tell? I will just explain it to you. Here we have the score. Score, or you can say score of weight of evidence. This is pretty clear. Now this is bad rate. This is your bad rate percentage. So it starts from 0. Let's say it goes to 2%, 4%, 6%, 8%, 10%, 12%. Now here the score falls from 500, then it's less than, let's say, 550, then this is 550. So this is less than 500. From 500 to 550 will come in this bracket. Then you have a bracket of, let's say, 650. All these are data points, guys. Try to understand. Now this will go less than 750, and let's say here the last trend will greater than 830. So all the brackets where the score is greater than or weight of evidence is greater than 830, that will come in a single way. Now what we will draw here, we will draw the bad rate. So let's say on this I will draw a bad rate. So this will be bad rate. Everywhere I will build. Once you will see the real data, you will understand. But try to grasp as much as you can at the moment from the conceptual perspective. All these lines are bad rate. So bad rate is increasing, decreasing with time. Okay. Now there will be a line for the total here itself with them. Sometimes total will be higher, sometimes total will be lower. I know this can be a bit too much for some of you, but try to understand, guys, because I will explain it in future when I will give you a real life example. So here we are talking about weight of evidence. How the trend check looks like, I am trying to explain that at the moment. Now how the trend will look like. So the line will go like this, will touch down this, and then it keep on going like this up. So this line is referring to weight of evidence. This red line is talking about bad rate, and this is your total. This is bad. So weight of evidence is fully defining the use or the weightage of that individual column here. Now let's go a bit more down. I will make a table so that all of you understand more in detail. When we are creating the weight of evidence trend, so we usually create a table where we have such columns. So one column will be bad rate. Then the second column here is going to be total. The third column is going to be weight of evidence. So we will write the value for three of them. Now let's say bad rate is 9.8%, then total is 5%. This kind of value you will see in real life companies, guys. At the moment, I am pretty sure you will not understand because you are coming from a fresher background. But when you will go to a company, you will see all these numbers. That time it should make a sense. So you will always remember bad rate, weight of evidence, total. These are all related to each other. Similarly, you have, let's say here 8.5%. So total will be, let's say, 5% minus 0.30%. All these things are calculated usually in all the company. Okay. So if you go to any MNC bank, you will see all these calculation happening at the moment. If I go on the mathematical side of it, it's going to be very tough. So you just remember from step perspective that in this step, we are checking the weight of evidence trend. Why I prepared this graph? To check the trend time to time. Okay. Once you will see the real data, you will totally grasp it. So here this weight of evidence trend is also completed. Now let's move on to the fourth point. Okay, what was the fourth point? Let me take you to the top so that you recall it. What was the fourth point? It's variable clustering or multi-collinearity checking. So let's do that. So this is your fourth point, which is multi-collinearity. Now, what is the meaning of multi-collinearity, guys? Overall variable reduction is very important. So all of you know that, which I explained also. Now, similar type of variables. What is the meaning of multi-collinearity? Let's say there are two variables which are moreover similar. They talk about any single prospect, either about age and total years of age. Sometimes there are replicated column. Let's say I'll take some more example. So first let me take an example, then you will be able to understand directly. So there are two columns which are moreover talking about the age of the customer. Sometime the name can be like this. So you will see that age and age of address. What is this mean? So at the present address, but that will mean age only. So here also it will be 27. Here also it will be 27. Or sometime these are totally identical, but sometime it can be different. Let's say EMI pending is one column, and then you have another column, due balance. So due balance, EMI pending sounds similar only in a loan portfolio. So, but you need to make sure that how much collinear they are. Okay. So similar type of variable should be grouped together, and we should make clusters. Clusters of similar variables is known as multi-collinearity test, which we do. Okay. So few variables can be chosen for each cluster. Few variables means depending on total number of variable reduction you have done at the moment. So it can be out of 300, 400 variable. In the end, when you will come at the end of the variable reduction, you will hardly see 20, 25 variable. Rest all you will remove when you are calculating a real life model. Okay. So few variable can be chosen for each cluster which have a higher information value and low R square. Okay. Forget R square for now. Just remember low R square and higher information value. Thus, this particular method, which I am going to tell you, used for variable reduction, also help reduce multi-collinearity. So we need to remove the multi-collinearity from the data. And for that, the equation is 1 minus R square. Just remember the equation for now. Okay. Then again 1 minus R square and own cluster. What is clusters? The combination of similar type of data type. Again 1 minus R square and nearest cluster. So this is going to be your equation in multi-collinearity. Multi-collinearity check is super important thing, guys. All of you should be knowing that. So here comes the end of step number 5 when you are creating a model. Variable reduction, performing all these checks like weight of evidence, information value, and multi-collinearity, you can remove at least 60%. I would say in real world 60 to 70% variable will be removed because those are unnecessary and you actually don't need them to create a live model in your day-to-day job. When you're working for a credit risk company, any big multinational bank, and I hope all of you want to work for like big banks like JPMorgan, Bank of America, Goldman Sachs, all of them, right? So let's talk about the next step. Next step will be step number 6. So variable reduction is done. Now the next step is the most important step, that is model creation. So in this step you are basically going to create the model, and this is going to a bit long also, but that's okay. So in model creation, this is further divided into 3 parts. Number 1, model training. Number 2, benefit of model on weight of evidence. Benefit of model on weight of evidence. Number 3 is going to be reject inference. So this part obviously takes more time because there are so many things involved in this particular area, because now you have done all the exploratory data analysis, everything in previous video I explained all of that. Now you have variable reduction also done. So now next step obviously is going to create the model, and creating model with the right set of knowledge is very important. Now let's start one by one. So the first topic is going to be model training. Model training. How model training basically works. Okay, so after the variable reduction, the set of variables are candidate variable for the model development. So first point here is after reduction step, which is just before this. After reduction, the pending variables are candidate variables, which are very important. Candidate variables. This is the super important part. Okay. Now, second point here is going to be that the training sample is used for actual model development. Okay. Training data, which I explained earlier, training sample, which is roughly 70% of your data, which you use as a training sample, is used to create real-time model. Okay. There are many model developers, okay, who use different technique, but the logistic regression using weight of evidence transform the variables into most common scorecard development model. So what does that mean? That logistic regression plus weight of evidence is the most effective scorecard model which is used in the industry. All of you should know that. Okay. The next point is going to be the model train is an iterative process. So there will be multiple iterations. Okay. Training is not a single-handed process. So training is iteration based, iterative process. So there will be multiple iterations. Keep on doing that. Okay. Conditions are checked to select the final variable. All of you should know that. Okay. If you have any doubt, please do comment. I will reply to that, guys. Okay. Now, some important point in the iteration. So the first point is going to be like chi-square test, which we call chi-square. Some people call it chi-square. Some people call it chi-square. So chi-square to test goodness of fit. It tests goodness of fit, like how fit the model is for this particular data. So we should be knowing that. So that's why we do this chi-square test here, and the higher the chi-square, the better the value is. Okay. The higher the chi-square, the better the value of the output will be there. Now, second point here is going to be p-value. P-value to test the significance of parameter estimate for each input variable. In general, p-value should be always less than 0.5. Just remember this. This is again very important point. Next point, variance. Okay, we check variance. So many statistical terms, don't get confused. On my channel, you will learn everything, guys, slowly. Now, variance inflation factor for test multicollinearity, we call it VIF, okay, was set for less than, it should be less than 3. In real life model, this will be the value. Just make a remembrance of this, okay. The final point is going to be in this training part. When you are when you have done with the chi-square test, when you're done with the p-value and then variance, the correlation between two variables should be less than 0.6. Correlation should be less than 0.6. Always remember these 4 metrics. This is pretty much clear. Okay. Now, this was all about the model training. I was talking about this point. So all this p-value, chi-square are part of point number 1. Now let's talk about point number 2, which is benefit of weight of evidence and building model on weight of evidence. Benefit of weight of evidence and building model on weight of evidence is a very important metrics. All of you might have understood it at this moment of time in this course, right? Now let's talk about quickly on this, because this is going to be really long otherwise. Guys, take a pause. So guys, let's talk about the first point in the benefit of weight of evidence and building model on weight of evidence. So the first point is outliers. This is going to be very precise, okay? So handling outlier without outlier treatment, that is a simple thing you need to remember. This is going to be point number A. Point B is going to be missing value. So we have already treated it, right? Handling missing value without imputation. Just remember that. Then third is, okay, let me write that, missing values. So you keep remembering when you're taking notes, missing value. Then C here is going to be monotonic relationship. Monotonic relation. Now, what is the meaning of monotonic relation? Grouping modular, similar type of variable on the basis of their relationship factor. Target variable we need to create, but similar type of variable, group them together. Okay. The next point which you should remember here is weight of evidence for various category of a categorical variable converted into a numeric feature. So categorical variable will be converted into a numeric variable. What is categorical? I said it, right? So you define the category. Let's say male, female is a category. Salaried person, business person, both are different categories. So we need to do that. That is one more thing. So categorization. All of those things when we are building the model. And final part in this is going to be scoring point. Okay. Scoring points. What is the meaning of scoring point? Model estimation can be translated to the scoring point using a adequate scaling or the data given by the business. You should be able to get that. So that is very much useful here. Now, this is benefit of weight of evidence and building model on weight of evidence. This was a simple point. Now, last point. The third thing which we spoke about is reject inference. Now, some of you can think, what is the meaning of inference? Oops, let me tell you. So guys, see, to develop an application scorecard, it is very useful, okay, to identify each borrower, either they are default or non-default, okay, that we understand. The default or non-default definition, whether a person is defaulting or non-defaulting, definition of the booked population is always known. What is booked? So when you are taking a loan, so first step is you apply for the loan, then they approve. So it's not always necessary that you take a loan. Sometime you don't take the loan after approval also. Those customers are known as non-booked. So they have not been part of the bank balance sheet. That's what it means. Okay. So however, if you know that a loan is approved, that doesn't mean loan is disbursed. Disbursement is a different thing. Okay. So the default or non-default definition of the booked population is always known. However, the performance for rejected population is also known. This is very important point. Now, bias can result if an application scorecard model is built only on the booked population and does not account for the rejected. So these are the people who has taken the loan. These are the main set of people, but you need to make sure that you are not making your model only on this population. That is a wrong decision. You should be taking these people also and booked people also, so that you have a clarity, because loan is disbursed. So what are those type of people who are applying for loan but they are not taking the loan? Okay. Now let's talk about the main topic, reject inference. So this will make a complete sense. The reject inference method allows to infer whether a borrower would likely to default or non-default for rejected application also. For these applications which are rejected by the client, they have not taken the loan, they took the loan from some other bank who gave a better offer. Now, this is known as a reject inference. I hope this is clear. Okay. Now, before I close this video, I'll make a very important graph for all of you. So how the loan is disbursed. So client come through the door. This is a terminology used in all the credit risk banks. Through the door, TTD we call it. After that, there is two things. Either accept the loan, bank will come, or bank will reject the loan. So there are two things which can happen. Now, if acceptance happen, so person will be booked. Number one, if the person is booked, that is fine. If the person is non-booked, that means that person will not be calculated in the balance sheet. So only these people will be calculated in the balance sheet overall for the profit perspective. Now, in this, there would be two cases. People will either default or non-default. So I hope this is totally clear. So this was the whole process of the life cycle of the loan. And in this video, we have spoken about step number 5 and step number 6 much more in detail. In next video, we are going to end this particular whole scorecard model life cycle, because step 7, step 8 are very important. Just stay tuned with me, because step 7 and step 8 are very important, because they talk about model validation. So many of you who want to work in model development team, this is fine for them, but if you want to get the knowledge of model validation also, you should be sticking with me. Now on that note, I would like to thank all of you for watching this video. If you like my effort, my teaching style, my content, do subscribe to my YouTube channel. Please hit the like button, guys, and please share this content with maximum people so that they can get benefit out of it. All the best. Thank you so much.